All right, let's talk about triangle similarity now. So we've talked about triangle congruence, and we know that the triangle congruence theorems and postulates are side, 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 angle, angle, and angle, angle, side. There's 4 of them. In triangle similarity, there's only 3 of them. So let's go over those 3. The first one I want to talk about is angle, angle. That says that if two angles in one triangle are congruent to 2 angles in another triangle, then the triangles are similar. That's it. That's all you need to know. If 2 angles are congruent, then the triangles are similar. So if I have a diagram, because diagrams are great, if I have this triangle and I have this triangle, and I know that this angle is congruent to this angle, and this angle is congruent to that angle, these 2 triangles have to be similar. That's it. That's all there is to it. There's no wiggle room. That's it. That's all I need to know. And this is a postulate. This is not proven. This is accepted. That if 2 angles in one triangle are congruent to 2 angles in another triangle, then the triangles are similar. So this triangle is similar to that triangle. And that's it. That's the first one. The second one is a theorem, side, side, side. The second one I'm going to go over. It's not the second one. My second one is side, side, side. This is a theorem. And it says, if the sides of one triangle are in constant ratio with the sides of another triangle, then the triangles are similar. So, a diagram is going to help with this one. Triangle. Triangle. So let's call this triangle A, B, C, and triangle D, E, F. Now, generally, as far as naming is concerned, when you're talking about sides of the triangle, they have the same letter as the opposite angle. So this would be side A, side B, side C, side D, E, and F. So what the side, side, side similarity theorem is saying is that C is to F as A is to D as B is to E. C is to F as A is to D as B is to E. Those are all the same things. Now maybe I give these letters. If this is a 3, 4, 5, this is 6, 8, 10. So all these sides, if I make the ratios, this is a 3 to 6, 4 to 8, 5 to 10. All of these simplify to 1/2. That's a constant ratio. All of these sides are in constant ratio. Every time I go from small triangle to big triangle, all the corresponding sides are in constant ratio. So these 2 triangles are similar. Now, yeah, sure. No, that should be it too. I absolutely drew these triangles to be similar, but yeah, it's an example. I'm allowed to do that. Why not? So yeah, side, 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 similarity theorem. The next one, side angle side similarity theorem, says if 2 sides of one triangle are in constant ratio with 2 sides of another triangle, and the included angles are congruent, then the triangles are similar. So, 2 sides are in constant ratio, and the included angles are congruent. So if I know that side A is to side B, side C is to side D, and this angle is congruent to that angle, then these triangles have to be similar. That's what this is saying. If A is to B as C is to D. So if this is 2, 3, 4, 6. If 2 is to 4, 3 is to 6. These triangles are similar. And these angles are congruent. You have to have those 3 pieces of information. So technically, for each one of these, we have 3 pieces of information. Now you might be thinking, this one's obviously only 2 pieces of information. But the cool thing about triangles is all the angles have to add up to be 180 degrees. So if I know these 2 angles, I can find that third one. If I know these 2 angles, I can find that third one. If these 2 are the same as these 2 will also be the same. So we actually have all 3 angles here. We just don't need to know all of them. I can find all of them, but I don't need to know all of them because I can find all of them. So angle, angle, I have those three angles. Side, 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 I have all three sides. Side, angle, side, I have two sides and an angle. The included angle, so maybe it's two sides and an angle. And that's the last one. Now, technically, the one congruence theorem that is not a similarity theorem is angle, angle, side. Now angle, side, angle also. So you might be asking why. Well, for angle, angle, side, and angle, side, angle, they're the same thing as angle, angle. If I know two angles, that's all I need. I don't care about an internal or an interior or an exterior side, or an included or an excluded side. If I have two angles, that's all I need. So angle, angle, side, or angle, side, angle don't really matter, because I have this one. And that's all I need. So yeah, that's it. Neat.